All right, here we go. Yesterday we left off right here. Somebody read this to me. And by somebody, I mean number 10. Read this right here, what's written to me.
It is... What? Wait, I don't...
You're okay. If you're wrong, it's all right.
G inverse?
Except it's F, but I love it. F inverse of X. Alternatively, number 5. How else could you say it? The inverse of F. Now, we talked a lot about these, and I'm trying to not get too, technically deep with it because I understand you might not care, but there are a lot of connections that we can make right now that we'll keep seeing throughout this year. Next year, if you take calculus, you will see more of those connections, and the better you understand it now, it'll be significantly easier next year. So I asked us a couple things. If the ordered pair AB is on F, then the ordered pair BA is on F inverse. So the domains and ranges, or the X's and Y's, everything just switches places. I asked you to graph this, I think. Okay, if you haven't done so yet, check it out. Why did I draw, oh, never mind, it's already written. Why did I draw the green line? Yeah, this is my line of reflection. Now, you do not have to draw all this, but if I asked you guys to sketch this, and I'm going to ask you right now, sketch this if you haven't yet done so, try to reflect that curve, F, over that line. And I'm going to take a look, just a quick glance at y'all's pages. Can you tell you're a little bit off? Just looking at it? No, so we'll check. Don't worry, you're good. Conceptually, I got it. Good, no, you're good, you're good. Okay. Now, as I looked around, everybody has pretty much had the same thing. I'm going to use a different color here just to indicate something. I'm going to use this gray color. If you reflect a point, should it go at this angle to reflect over the green line? Should it just go straight up like this? This point is just going to go straight up and reflect right here. Does that look right to you? You probably want to use a P word of some sort. Followed by perpendicular. Perpendicular, right? So, if I were to do this perpendicularly, do you agree that that's pretty close to perpendicular?
Yep.
So, just looking at it, it means that I think with fair certainty that this point right here, when I reflect it, that point right there is where it would wind up. That's this point reflected, maybe a little further. Okay, I'm going to eyeball this one. If I go here, would you agree that that's probably about the same distance perpendicular? I'll do it here as well, and we'll see it's getting closer, which it should. Down here, I'm just going to do a couple more. I think that point looks like it. This point down here looks like it. Close, roughly at least. And then they start getting closer again. Now, you don't have to do this on every single one, but if I draw these lines, what I've reflected, and I'm going to try to cross through them. Oh my gosh. All right, we're going to start here. Does that look to you like it's just kind of been reflected? And does that look to you like it's just kind of been reflected? And it almost looks like a nice double helix. The only issue, Rafa, that I had with yours is this part bumped out a little further. If you had a bigger graph, it would be easier to do. I don't think there's misunderstanding. Conceptually, does that feel okay? All right. So you do not have to draw these next ones. We're going to continue on. You will have time in class today to work, which makes me hope and think you won't have homework. Turns out there's a graphical test that we can use for the existence of an inverse function. I want you to write this part. In your notes, we're just continuing on. The main topic that we're in right now is graph of F inverse, or graphing F inverse. I just want you to write the words. We're going to use these pictures to make sense of stuff. Graphical test for the existence of an inverse function. Language, super duper important here. Graphical test for the existence of an inverse function. Don't leave off the word function. It is super duper important. Wow. Right, that's block. Yeah, block. Cool. Do y'all have that written down? It is entirely up to you. If you want to draw these graphs, you can, but I'm probably going to go through them faster than you can draw them. So keep that in mind. All right, as we look at these, I have three functions, I think. I've named them f every time. I don't really care what the names are. I guess the first question that I really care about, though, is are these functions? Why? How can you tell? They passed a vertical line test, jinx. Now, as we go through, I can see that they, in fact, do. I'm going to just real briefly try my best to roughly sketch what I would call the inverse graph. Now, it's just reflecting. I don't have to be perfect. I just want to think about it. Do you agree that on this little section here, it would probably scoot out like that? It'd be curvy, but I can see that it almost just looks like a line, right? And then here it looks like it's going to do, I'll just reflect that point over to there maybe. Maybe do something like this. Or something like that. Do you guys agree? Okay. Here's my little concern. That's the graph of the inverse. Is it a function? You may have some hesitancy. Quietly talk with your neighbors. I want to see why. And actually, my graph didn't reflect super well, did it? It's okay. I'm going to spend a little bit of time making it a little bit nicer. And I'll have you guys check it out for me. The only question at hand is this thing a function? So that point's on both, and that point, and this point, and that point, and that point. There we go. What do you think? Now, just real quick, nobody wants to volunteer. That's fine with me. Thumbs up, you can be guarded if you want. The purple one, the second one I've drawn, is a function. Thumbs up, it's not a function, thumbs down. Love the divisiveness here. Thumbs downers, why? Gosh, that middle bit kind of looks like it's vertical. Now, here's the other thing that I really want to pay careful attention to. I'll tell you, it's not. And there's I like that idea. This graph, I just picked a random one and thought about it. I'm going to make up an ordered pair here. Let's say that this point right here is a y value of, I don't care what the x is, something comma b. Are you guys okay with that? What would this ordered pair be then? Something comma what? So is it negative b though? Is it the same y value? Okay, my bad. You were correct if it's just b. Those points are both on the graph, right? When I flip the x's and y's, I get the same new b value as an x, but it spits out a different value. We fail the vertical line test here. Now, it's harder to tell just by the graph, and I wasn't trying to trick you guys with it, but it definitely does in this middle section. It fails that test. Now, what about this one? If I reflect it, it looks something like this. I did poorly. We'll do that better. Is that a function, the purple one? I think so. What about this one? This one's a little harder to do. Is that a function? Now, what we've just discovered is a few different things. First question, do you guys recognize any of these graphs? This is x to the what power probably? X cubed, cool. Nice use of your parents. This other one? Square root of something. And this one? E to the x. Now, the fact that I can draw this thing, I've drawn the inverse function based on this graph. On the third one, I drew an inverse that was a function. I drew the inverse function. On this, was I able to draw the inverse? Careful. Are you sure I couldn't draw it? I drew the inverse, but what was it not? A function. One more. I'm just going to sketch one here. What about a parabola? If I draw a parabola, I'm pretty sure a parabola is a function. I think it is. Yep, it is. If I draw this one, and it's red and I hate it, but that's okay. If I draw this graph, and I were to reflect this, what would it look like? It looks like this, I think. So, the original is a function, is the inverse a function? No, because we saw in each of these, it failed the vertical line test once we reflected it, right? Now, it turns out there's an easy way to spot this. On that first graph, we just highlighted that, hey, two of the y values were the same. Vertical line test doesn't tell me anything about this. However, maybe you've heard this before. We're going to make a quick comment here, and this is super duper easy to state. A function, here we go. Big important statement. Back to writing. A function has an inverse function. If and only if, which is just IFF. If and only if it passes, and let's think this out. I'm going to let you guys catch up. A function has an inverse function. That language is so specific. If and only if something. If you have a vertical line and you reflect it over y equals x, it changes to this. It changes to a horizontal line. So to check if something is a function, we just use the vertical line test, right? To check if it has an inverse function, we are going to use the horizontal line test. You will never see me write this again. Horizontal line test. What's the hollow way of writing this, do you think? Indeed it is. HLT. This is such an easy way to check whether or not we have an inverse function or not. Or if we wanted an inverse function, where might we restrict the domain? Or which x values could we choose that would still produce that function? So, turns out that this has a big name. I'm going to sneak in a couple words. Have you guys ever seen the word injective in mathematics? Okay. How about, I'm going to write some of these in parentheses. Injective is the real true word that we're going to use. How about this? 1, 2, 1. Do you remember seeing 1 to 1 in Algebra 2 last year? So I saw somebody yes, somebody no. Just so you know, I would never write the words here. I would do this, and it looks kind of like a TIE fighter from Star Wars. That's my 1 to 1 shorthand as well. Okay. All that this means, a function can be injective, or if you'd rather, 1 to 1, if the following is true. If it passes a horizontal line test, it's injective. That's what it means. Specifically, we'll say for every y value, and you could say range if you would rather, but y value is sufficient for our purposes, exactly one x value maps to it. Now, this is fancy language, and the 1-to-1 language is nice. Injective is the real true term, but for every one x I plug in, I get one y. That's just a regular function. But for every one y that shows up on my graph, there's only one x that goes. It's a 1-to-1 correspondence all the time. When we run the horizontal line test, I'm checking to see if my function has two different x's that spit out the same y. If it doesn't, I have one y for every x, and my function will be said to be injective. All of a sudden, there's a big connection. Instead of saying if it passes the horizontal line test, what else could I say here? A function has an inverse function if and only if it, and don't actually get rid of yours, but could I say is injective, and it would work the same way? Injective is what's telling me if I'm 1-to-1, and it guarantees the existence of an inverse function. There's a lot of language here. Should we do one more quick picture? Okay, so check it out. We're going to make a function, two functions, one that's not 1-to-1 and one that is, or injective if you'd rather. So my quick question is injective? And that's it. So on A, let's say we get this lovely graph. Of some function f. I just made it kind of wiggly. I mean, that's like a fifth power, fifth degree, x to the fifth. Don't know, made it up, doesn't matter. Is that thing injective? You say no right away. Love it. Why? If I do the horizontal line test, I'm going to try to see if I can make this work like this. I don't know if it will. We're going to try it. Boom. All right. Right now, how many times am I touching the function? Once. Now? Maybe more than once, but I can't tell for sure, right? Well, right here. Twice or thrice, depending. But is it at least more than once? What this means to me is this function injective? Does it have an inverse function? That's a harder question. Not injective, or 1-to-1 if you'd rather. No inverse function. Now, for this, we can do a small little expansion on this problem to make it work. Where did the issue start to happen? You just holler out when my function no longer worked. Still good, still good, still good, still. It's like right here, yeah? So check this out. If I had only taken, and I better draw this so that if you're watching it later. If I had only used the part of the graph that did pass that, for example, I only used it to right there, possibly. And I restricted the x values, or the domain. Does this one now have an inverse function? Absolutely. You guys already know of the existence of inverse sines and cosines and arcsines and those things. Do you remember what the graph of sine looked like? Just a big wave, right? If you stick one little part of it so that you don't ever hit two y values, you can turn it and it still passes it. It's the same thing going on here. You may restrict the domain to make it injective, or in other words, to make its inverse exist as a function. So one more, I'm going to challenge you guys. Draw me a bendy curve, not a line, that is injective. Draw me an injective curve of some sort. You're good, just up there. You're good. So careful. Love
Yes,
this.
it is.
It wouldn't make sense.
It's not
I can't draw the line. Yeah.
I got it.
Any issues with this being a function?
Shooting?
Possibly, like if you wobble back and forth, and it's just because it's small, not for like any other issue than that. It might not be a function, so it might not even make sense.
I don't know. It's not working.
Love it. Love it. Yep, I do. Do I? I gotta look at it. Yep, I do. Love it. What are you erasing?
You like it?
Sigma.
See? Shut up.
Is that a good thing, I assume? Must be.
Okay, got it.
Good. Good. You're pushing the boundary a little bit there at the end. Good. Okay. Check it out. Because I asked for a curve, it doesn't have to be anything crazy, but it could be. Only one person drew something crazy, which is totally fine. Some people drew something like this. It's a curve. Is that 1-to-1? Yeah, check it out. I'm good everywhere, right? Okay. Somebody did this, and they made it a little bit crazier. That's fine. Is this also fine? Maybe. It depends on how specific you're drawing, right? Like I can see maybe in here, but I would have to look a little bit closer. This one, right, the way I've seen it, the way I've drawn it anyway, is not. What about somebody wants to make it wobbly? Like that. Is it 1-to-1? I'm going to make the claim. It doesn't make sense to even say this thing's 1-to-1 or injective, because those are adjectives we use to describe a function. Is that a function? It fails. Doesn't even make sense to say this is injective. It's not a function. Okay. Good trick question there. Doable? Easy? Hard? All right. Last little thing today. It's find a graph in inverse. We can do that. It just reflects over which line? Y equals x. Remind me, what swaps places between my ordered pairs? Give me the other language. You're good though. X's and Y's or Y's and X's. Domain and range swap places. So we have looked at what it means to be an inverse, what it means to undo something, whether it's multiplication or addition or functions. What's the identity in the land of functions? That I plug in a 5, that function spits out a 5. X. How do you check algebraically if something's a function? Like, if I just asked you, you don't write this down, this is just review out loud. If I wanted to know if f and g of x were functions, how would you determine? Or sorry, not functions, inverses. Without graphing them, because you're never going to trust your graph anyway. Clouds look like it's getting a little lower out there. We might be bogged in. Planes can't land because of the... Oh, why am I making you say that word? The composition of f with g. Okay, if these are inverses, this is going to be what? That's the same thing as this, which better be equal to what? Every time, anything but x, and you're done. Cooked. You're done. I like that gal. We're not going to quote other parts of her videos, but are we all thinking about the same person? Do you guys think about the gal with Tourette's? Oh my goodness. I'm pretty sure that's where it comes from.
Oh, the girl that would, yeah.
A girl with Tourette's, and she drops like some hardcore explicit language. I mean, it's not really that hardcore. Everybody. Do I swear in my spare life? Whoa, spare time, free time, life? You think so?
Yeah.
Yeah, you've probably heard me say some terrible things. All right. Nothing offensive other than the profanity. Let's do some problems. We want to not only verify that things are inverses or graph them, but can we all agree that graphing maybe kind of sucks? I actually don't mind graphing. It gets so much easier. Like, it's so weird to think because this is like the highest math class you've ever been in. Everything that's higher looks intimidating because you might think it's scary and harder. If you are good with algebra, most classes beyond this aren't any more challenging. But what they do is they make everything that we do now so much easier. Problems that might take like a whole page of work in here could be like a 2-line problem in a calculus course once you have those tools. But we got to make sure we have the algebra to develop the tools. Anywho, let's find an inverse function. Finding f inverse of x. Okay, for this, we're going to do it algebraically or analytically. I don't know which one you guys prefer. I switch back and forth pretty freely. Analytically. Okay. Instead of just saying, here's the steps, and then doing a problem, we're going to do them simultaneously. We're going to say, here's the steps we're going to follow, here's our starting problem, and then we're going to roll through. So, right off the bat, let's do an example with the steps. So here's our steps that we're going to look at, because it's a super easy process, and then here's our example. And I will change colors at each step only so that we can distinguish between them because the writing here may be more or less than the writing there. So check it out. Let's look at this. We want to start with some function. And this is like step 0, so I'm not even going to write a step here. Let's work our example. Let's think of a function f of x equals, let's don't go too crazy here, bless you, the cube root of x minus 5. So something f of x equals the cubed root of x minus 5. Okay, there's no step there. That's just where we're starting. I should have written it first, but I was already committed. Okay, step 1. Do you guys love the idea of having to carry f of x through a whole problem? Like writing it over and over? What might be easier to write over and over instead of f of x? Because we need something shorter to write it. No? Okay. All right. So, step 1. I agree that I would rather use y. Finally clicked, it looked like. Took a little while there, but that's okay. Step 1. Right off the bat, replace. What do we want to not write anymore? F of x with y. Boom. Easy. So over here, same color, step 1, instead of this monstrosity, we instead get y is equal to the cube root of x minus 5. Okay, nothing wild. These next two steps are interchangeable. I don't care which way you do it. I know how I prefer to do it. And actually I don't. I'm just going to write down whichever one feels more naturally. What switches places between a function f and its inverse? The domain and range, which, give me another way to say that. The x and y. So, in this situation, when I do this, I would say swap every x with y and vice versa. Do you guys know what vice versa means? The other way. It's literal in Latin. We're going to Google it as soon as we're done with this problem because I don't know what it means. I'm sure it's Latin though. Okay. When I try to do this over here, step 2, and that wasn't circled, what would you write instead? Anywhere that there's an x, I put a what instead? And anywhere that there's a y, I put a x. Okay. So this is x equals the cube root of what? Y minus 5. Now, conceptually, I just wanted to make sure that we're all cool with it. Literally, we just swapped the domains and ranges. Not figuratively, we literally just did that when we wrote that line. Now, it seems weird to solve it for x. What's more natural to solve for? Let's solve it for y. So on step 3, solve for y. And this is where I'm going to need your guys' help a little bit, and where the maybe columns don't make as much, they don't line up as nicely. I'm trying to solve for y. Whoever's phone's buzzing, or no, I'm good. Okay. Weird. I heard strange. Do you guys ever get phantom vibrate like in your pocket? Yeah. I've never had phantom noise, but it just happened. Weird. I'm sorry. All right. Help me solve this. Algebra muscles. Let's flex them. We getting swole. Number 1, what's the first thing you want to do? I don't know who number 1 is. On which side of the equal sign? Both. All right. Now, I don't know if I've ever actually asked you guys, do I write enough work for everybody? Just yes or no. It's okay if it's no. I will try to write more. When I cube stuff, I don't know the right way. Have we talked about this, that I'll do it like this? Have we seen me do that? Okay, how do I normally write it? Because I teach like 3 classes that all have similar ideas and I get them mixed up. I could do this and say cube. Which one feels more natural? Okay. So the other thing you'll see me do, and I'm not going to do this all the time, but because I'm lazy, sometimes I also just do this. What do you think it means I'm cubing? Everything on the left and everything on the right. I would be wary. I'll stick with the first one for now. Okay, cubed and cubed. I'll do the left side. It's x cubed. Uh-oh, right side. Who wins when you cube that number 5? What do you get? Y minus 5. Now, real quickly, I just want to highlight something. The cube undid the cube root, right? Literally just an example of our inverse operation. Cool, just like adding a 0 or subtracting a number or multiplying by a fraction. All right, 1 step away. Everybody, what do we do? Okay, solve for y, and am I going to drive anybody crazy if I do this? Realistically, there's 2 steps there, right? I'll show the 2 steps just in case somebody's looking at like, what? Follow-up imaginary bonus points. Which property allows me to move from here to here? I don't have a good way to do it other than that. Symmetric property of equality. Okay, cool. You can move from left to right. Okay, one more step. Kind of. Really, we're done. but I'm kind of a stickler for notation, and I want to make sure that we clearly identify what's happened. This entire process, conveniently hidden here. We are doing this to find the what? Kind of the y. The inverse function. Man, if only there were some notation that said, look at it, this is the function that is in inverse. What are we going to replace y with instead? Replace y with, in this case, it's f inverse. But remember, if it was g, call it g inverse. If it was h, call it h inverse. Arc f is a terrible language. There's one more thing that's not really required step, but it is valuable to have. So here's me writing this as an inverse. This problem, hopefully not like wildly challenging, but there's a couple things. Is it possible that somebody makes a silly mistake on your math throughout the process? Happens all the time. Silly math mistakes, SMM is maybe what I'll go with. They happen. On a quiz or a test, like on a homework, this is where I'd stop. On a quiz or a test, though, would it be nice to be able to verify that you are correct with certainty? If these are, in fact, inverses of one another, how would I check that to verify that I didn't just mess up? You could graph them, but we're not going to just trust our graphs. You could, what do you mean plug in? So check it out. Your guys, I think, will be like, oh, okay, yeah, that makes sense. I hope. If I wanted to be very certain of this, you could call this step 5, I suppose. I'm gonna say check, and there's two things that I would really check. I would check f of f inverse of x. And what's the other composition I should check? F inverse of f of x. Now, and these should both equal what? X. When you're doing this, and just in practice, just so you know, do y'all agree that this notation is just begging for somebody to make a typo or a righto or a, I don't know the right word for it. I'm going to call it a righto. Because that's like gross, yeah? Pretty common. I will, if I'm doing a problem and I'm dealing with a function and it's inverse, I'll say let g equal f inverse or something of the sort so that I can avoid making a mistake with writing stuff. Okay. Anybody want to learn a sweet shortcut? This one, you will be able to do in your head. And I'm going to walk you through the shortcut. If you want help like writing the words, you can. This is a process that I want you to practice. I lied. I'm going to give you time to work on your homework right now. In about 15 minutes, I will show you a shortcut because I want you to do some of these. So, starting right meow, we have homework time, but specifically homework time with 1.9 located on page 90. 90. And you guys have been killing it, by the way, getting your homework done. I don't think anybody in here has missed an assignment yet. If we get through the whole quarter without anybody missing an assignment, I'll bring in donuts. If somebody misses it, I'm going to put your name up everywhere and say, you lost our donuts. Not really. That's hardcore. I will not tell anybody who it was. But I'll tell you at the end of the semester. Quarter. Okay. Let's see. We're going to try something different today. I'm going to call on a few people here in just a second, and we'll just, everybody listen up because we're going to save some time. If f and g, when we compose them, f of g and g of f, if they both equal x, then those functions f and g are what's of each other. There is too much language. Can I steal your book for like 30 seconds? Because mine has the words written in it. I don't want you to do it. The vocab stuff, I think I might not keep giving you vocab. I like the vocab because it's important that we can speak about it. But, okay. Composites, f composed with g and g composed with f, they both equal x. They must be what? How would you write the inverse of f? F with a, not an exponent, a superscript we'll call it. F to with, is it that? I'm just trying to avoid having to say the incorrect language. F inverse. Cool. The domain of F is the what of the inverse? The range. And the what of F inverse is the range of F? Domain. Okay. The graphs of F and its inverse are reflections over which line? Not y-axis. Y equals x. But there's language there that's easy mistake. A function f is blank when each value of the dependent variable corresponds to exactly one value of the independent. For every one y, there is one x. Injective. Give me the other good name, but not. Ooh, that's a fantastic word. If you didn't hear that, Angel just said onto. You guys must have talked about one-to-oneness last year and onto-ness. Surge activity. Maybe not. I don't know. Is that what you said, or did I mishear you? I was so excited about onto. All right. You guys should have seen onto functions last year, though, just for the record. One-to-one. 1-1. You can draw your TIE fighter. The word injective is cooler. And a graphical test for the existence of an inverse function of f is called the... Correct yours? Or yours? I don't know who said it. Did you say vertical? That's super easy. Vertical is for test to see if it's a function. What if you want to test if it has an inverse function? Horizontal, HLT. Cool. I'm not going to make you guys write the vocab. Cool. All right. So I'll give this back. We just cut out 6 problems and saved ourselves, I don't know, hopefully a little bit of time. All right. You guys get the privilege of working problems 21 through 25. Only algebraically. It's going to say graph it. Don't do it. 21 through 25, only algebra. And then beyond that, just a few more. 37 through 40. And then this is going to be super irritating, but I might make you start with different ones. I want you to actually start, and this is going to seem super weird, but I want you to start with these last few. I want you to do 57 through, oh, I love it. How many inverses do you want to find? How many do you think it takes to get good practice? 57, 59. I'm going to give you 4. 65. Awesome. And 70. Do these 4 first, and then I'll show you a shortcut. Cool. 10 minutes, I'll show you a shortcut. Start with 57 through 70. Yes, yeah, it's fine. Cool, cool, cool. Be sure to smash that like button.